Hello friends, myself Aher DR from RBNB College Srirampur. Today I deliver a lecture on mechanical properties of solids from 11 Science as per Maharashtra State Board. In this chapter we have to study stress-strain curve. For studying stress-strain curve, again we consider a metallic wire. Its one end is fixed to the rigid support. To the free end of the wire, a suitable weight is attached in the step of 500 gram. And we increase the load in step of 500 gram, then we observe the relation between stress and strain. That curve is called as stress-strain curve. Now in this stress-strain curve, stress is plotted along the y-axis and strain is plotted along the x-axis. O is the origin of graph. Initially, as we increase the load in step of 500 gram, the nature of graph is straight line passing through the origin up to point A. This shows that stress is directly proportional to strain. As stress increases, strain also increases, and up to OA, Hooke's law is obeyed. This A point is proportional limit. It is called as proportional limit. Up to A, wire having elastic behavior, or this region is called as elastic region. So in this region, stress is directly proportional to strain, and therefore we can say that within elastic limit, stress is directly proportional to strain and Hooke's law is obeyed. Because we know this statement of Hooke's law, within elastic limit, stress is directly proportional to strain. This A point is called as proportional limit. Now if we decrease the load, then wire regained its original dimension. And that's why this region is elastic region. So this region is elastic region, or it is also called, it obeys the elastic behavior of the wire. So we write up to A, elastic behavior is there. Now if we increase the load in step of 500 gram beyond the point A, then nature of graph is not straight line, it is curve up to point B. But if we decrease the load, then it regains its original dimension. And again, stress is directly proportional to strain, but nature of graph is curve. So this B point is called as elastic limit, and therefore this point B is called as elastic limit. Within elastic limit, what happens? If we decrease the load in step of 500 gram, then wire regains its original dimension, and therefore this point B is called as elastic point. It is also called as yield point. It is also called as yield point. So again, remember that nature of graph is curve, but there is elastic behavior, and that's why within elastic limit stress is directly proportional to strain. If we decrease the load, then wire again regains its original dimension. Now if we increase the load beyond the point B, up to C, this point is say C. Then if we decrease the load, then there is permanent deformation remains in the wire, and which is given by OS. This OS is permanent deformation. Remains in the wire. Now this is the elastic behavior of the wire, but this is the plastic behavior. Now if we increase the load beyond point C, if we increase the load beyond point C, then finally at D, this D point is called as breaking point, or it is also called as fracture point. When wire reaches to point T, if we decrease the load, once fracture point, at that fracture point wire becomes thin and finally it breaks if we decrease the load, and therefore this point D is called as breaking point, or it is also called as fracture point. So this point D is, which is on this stress strain curve, it is called as breaking point or fracture point. Now see here, up to C, or from the point B, C, D, this is the plastic region. In this case, wire become plastic, and that flow is called as plastic flow. And finally at point D, wire breaks, and that's why this point is called as breaking point or fracture point. So in this way, we study about this stress strain curve. If we increase the load in the wire in step of 500 gram until wire breaks. Now concentrate on this point B, C, D. This point BCD is a plastic region, or that is called as plastic deformation. Or it is called as plastic deformation. Depending upon this plastic region or plastic deformation, there are two types of material. One is say brittle. What is brittle substance? In this brittle substance, wire breaks within elastic limit. Means after B, wire suddenly breaks. Such type of substance is called as brittle substance. So in case of brittle substance, we can say that it is a material in which wire, or it is a material in which it breaks in a elastic limit. Such substance is called as brittle substance. So after B, it breaks. Such type of substance is called as brittle substance. If you consider glass, ceramics, these are the examples of brittle substance. In brittle substance, after the elastic limit, it breaks, and that's why it is called as brittle substance. Now there is another type of substance, it is called as ductile. What is ductile? Ductile substance. In this plastic region is considerable lengthen, or it is large. Means this BCD region is very large, and finally that breaks at point D. Such substance is called as ductile substance. Plastic region or plastic flow is considerable lengthen. Such substance is called as ductile substance. So in that case, this plastic region means BCD, this BCD region is plastic region is very large. If you consider this region from this one, this plastic region is large, then such type of substance is called as ductile substance. So depending upon this plastic region, there are two types of substance, brittle substance and ductile substance. If this region is very small, then it is called as, substance is called as brittle. If this region is large, then such type of substance is called as ductile substance. For example of ductile substance, we consider copper, aluminum. In that case, this plastic region is large, and finally substance get breaks. Now we have to study about another type of substance, that is called as malleable. Malleable substance. If substance is hammered, then it is converted into thin sheets. Such substances are called as malleable. If substance is hammered, then it converted into thin sheets. Such substances are called as malleable. If you consider gold, silver, these are called as malleable substance. If we hammer this silver or gold, then it is converted into thin sheets, and that's why such substances are called as malleable. Now there is another type of substance. If you consider rubber, now in case of rubber, it having large elastic region. So we have to study about the elastic elastomer. So what is elastic elastomer? In such case, there is large elastic region and nature of graph is curve, not straight line, it is as like curve. Such substances are called as elastic elastomer. So according to this, we can say that what is elastic elastomer? Elastic elastomer means a material that has large value of strain. It is called as elastic elastomer. If you consider rubber having large elastic region and its length may be large, many times greater than its original length. After the removal of stress, it regains the original dimension. But nature of graph is not straight line, it is curve, and that's why such substances are called as elastic elastomer. In simple, we can say that what is elastic elastomer? Elastic elastomer means a material that has only large value of strain. It is called as elastic elastomer. Now we have to study about the elastic hysteresis. Elastic hysteresis. What is elastic hysteresis? So in case of elastic hysteresis, we consider a graph as like this was stress-strain curve. Along the y-axis stress is there, along the x-axis strain is there. If we consider increase in the load, then stress curve is as like this one up to this point when we increase the load, and when we decrease the load, the nature of graph is as like this one. This total area under this loop gives us energy of dissipation. This gives us energy of dissipation, and this is called as elastic hysteresis. In this case, the lagging of strain behind the stress. In this case, strain is lagging behind the stress, then it is called as elastic hysteresis. So in short, we can say that what is elastic hysteresis? The lagging of strain behind stress is simply called as elastic hysteresis. So this is about the elastic hysteresis. Now in case of elastic hysteresis, with the help of graph, we can study the elastic hysteresis. When we increase the load, then stress-strain curve is like this one. Stress-strain curve. When we increase load, as like this one. And this is the nature of stress strain curve. When we decrease the load, from this graph we observe that strain is lagging behind the stress, and that is called as elastic hysteresis. So this is about the stress strain curve. With the help of this stress strain curve, we study the elastic behavior of wire under the increasing the load. Now we stop here. Thank you.